So we learned about Flux, and the next talk is going to be in that same vein. So Bonnie is going to tell you how she architectured the code editor at Codecademy. Bonnie.
Great, thanks. So hi, everyone. My name is Bonnie. After the Flux panel, now I'm going to tell you about how we don't use Flux at Codecademy. So this is how we approached what we think of as component communication. So with that, first, a little bit about me. Like I said, my name is Bonnie. I'm a software engineer at Codecademy. I'm one of a team of 7 engineers total in the company. There's 3 to 4 of us who work on front end in React every day. And I posted these slides on Twitter in case you're curious. So there's my username. OK, great. So today, I want to talk to you first a little bit about the context in which we use React at Codecademy, how we came to it, and what we need it for, which is relevant to how we decide to approach sort of data flow and communication problems. After that, I'm going to actually tell you what we needed it to do in terms of communication, what we did, and then some musings on what might work better, what kind of patterns can we draw out of this. So first things first, Codecademy. In case you haven't heard of us before or used it, we teach people how to code for free online in the browser. So this is the current interface, the one that we rebuilt totally in React about 6 months ago, so that was exciting. We needed to rebuild our entire front end for product reasons, actually, because we wanted to teach things that were sort of too complicated to do in our old system, which was much simpler, just had a code editor always. For example, this is a how to make a Rails app course where you learn to basically make an Etsy clone. Yes, Etsy approved this. So sometimes there's a web browser. Sometimes you have a bash shell. Sometimes you might eventually not even have a code editor at all, say, if we want to teach you command line tools. So because of that, we needed something much more flexible than our old UI. We had an opportunity to rewrite a lot of the front end, build a new Codecademy, and therefore we had a chance to choose a JavaScript framework or library. And so why React? Happily, our CTO has already answered this question on YouTube in another talk. For us, it was a mixture of a lot of things, like, again, preaching to the choir. We all know that React is awesome for a lot of reasons. So for us, a big part of it was server-side rendering. It was the fact that it seemed like a really reasonable way to do things and think about stuff. I love the fact that my UI elements are now like state machines that I can actually think about. So that's cool. So I joined the team about 6 months ago. And at that time, it was actually the exact week that everyone was trying to learn React. So that was a fun moment to join. And none of us had used React before. We'd heard some things about it, read some blog posts, and we needed to basically start learning and start building out some smaller examples to learn how to do this for our main application. So the first thing we did was RTFM, right? Read the tutorial. OK. Looked at some sample code from Codecademy too, so thanks, guys, for putting that out there. That was helpful. And it took us a little while to start to learn how to think in terms of React, right? Props, state, OK. Unidirectional data flow down the component tree made a lot of sense to us. That was cool. But because we're this big single-page app where there's a whole lot of feedback that we have to give the user when, say, they have an error in their code or stuff like that, it wasn't enough for us just to be able to communicate down the component tree. We do a ton of communication up and across it, too. So if you read the tutorials, the answer to this problem actually at the time, 6 months ago, seemed to be just put callbacks places. And that'll just work. I know, having followed the Flux panel, that you're like, well, why not Flux? And honestly, the answer was that we didn't know about Flux. It wasn't really explicitly included in the docs. It was like a footnote at the bottom of a column somewhere. There had been, I think, maybe a couple blog posts about it at the time. It's totally possible that we were just blind and missed it. But in a lot of ways, this talk is going to be about what we sort of naively did to try and fix this problem that we had. So callbacks were what we thought the docs said that we should do. And OK, so this is our app, right? Well, what happens when the user hits run? Well, if we want to compose this into big components, we have an instruction section, this code editor, a browser, toss in some smaller ones. OK, when they hit run, OK, so we populate that up to the learning environment, which talks to the backend, which gets the result. And then, all right, we have to give them feedback in like the instruction item, like a checkbox or a X. The code editor has to show errors. Maybe the browser shows errors if they failed totally to like type in a URL. And the navigation has to activate if like they pass the exercise. So like a lot of stuff, right? Just because they hit a button. And so obviously for us, just use callbacks wasn't good enough. And I think this is interesting because I've definitely talked to people at this conference like today and yesterday for whom just use callbacks is perfectly good enough, right? If you're building a simple app like the simple demos that are in the tutorial, that works. For us, it didn't. And so we sort of took a step back and started thinking about what we needed from data flow to move up and across the component tree. And like the first two on here, like, yeah, we need our code to be reusable and legible. Like everyone needs that. That's not as interesting. The big ones for us were twofold. Passing state changes up and across the tree, like I said. I got to a point where I was thinking about like changing the state of a component's fourth cousin twice removed, and I was like, I can't even do that. Like, I don't know what that means in my real family tree. I don't want to think about that for my components. And then the other thing is that for us, adjusting to changing communication targets. This is a single-page app. We change which exercise you're on just by twiddling some state, right? So is there going to be a web browser? I don't know. At any given point in time, like, I really don't want the whole application to have to think about that. But that being said, you know, most of our communication needs are pretty basic. We're not doing something like, say, Facebook and dealing with like massive amounts of data coming in from the back end. A lot of this is just responding to user interaction on the client side. So what we did. So I'm going to go into sort of how we approach this, and I think you might see some interesting patterns emerge in the ways that this does and doesn't look like other solutions that we've heard about today and yesterday. So we came up with these things called adapters. Please don't talk to me about the name. Some people have already complained about the name. So the big parent component, the learning environment, which is sort of like our one component to rule them all, right? It always has an adapter. And this is built based on what we call major components that are present, which might be a web browser or an instructions section or a code editor or a terminal. And then we have these communication events. Components can broadcast them, yada, yada. OK, cool. This creates a very simple diagram, right? So major components broadcast stuff. The adapter thinks about it, responds, and then calls set state directly on the major components, which then propagate that down to smaller components via props. OK, neat. And of course, like sometimes, yeah, we do have to run to the back end and ask for stuff. But like I said, our application is not so heavy on like, you know, fetching huge amounts of data. We do some interesting things with like how we run the user code. But in general, we just said adapter, you worry about that. Major components, we just call set state. And then you're just a React component. It'll be fine. And so this actually worked out pretty well for us. So again, here's the app. And so that was an example. If you see, we have an instruction section, a code editor, and a web browser. And so we create an adapter out of this. And you know, eventing systems, boring, right? For us, the important thing is that we can compose them out of lots of modular parts. So we say that the adapter for this scenario needs to be able to do these 6 things. This is a little bit like, obviously, of a modified example, but there's the piece that talks to the backend. There's like this tester that actually runs tests. There's a content editor that our local like in-house lesson writers use to like preview their lessons in the actual interface, stuff like that. And then, oh, by the way, there's a browser, instructions, and code editor. All right, cool. And then the adapter just kind of ends up being the state dispatcher. It listens to events, it responds. Cool. And in use, it ends up being pretty simple for us to make use of this. Creating an adapter is a one-liner. That's fun. It's based only on which components you have. And then the only management we really have to do to make sure that our custom communication system plays nice with React is make sure that we pay attention in component did update and just recreate an adapter whenever the exercise changes. And I think it's important to note here that because of the way we're hooking into this, we're making a lot of assumptions about how our communication system ties in with the nature of this app. And we're able to do this without really caring, honestly, because Codecademy is one big single-page application. And obviously, we want this adapter system to expand to future projects, but we sort of built it with that in mind. This is not like a very general design pattern. This is like very specifically, we knew what we needed to get done here. OK, so we have an adapter. Now instead of the run button having to like have this callback that's like passed down through 10 generations, like the way that the relay team showed off with like, you know, the passing down props that don't matter to the intermediary generations. Now we just pass down this one prop. It's broadcast. Broadcast is cool. The run button triggers this event. That's great. The adapter listens to it. It talks to the backend, runs back, and then all the major components get their state set. Like, you know, that's fine. That works for us. Defining an adapter. And like I said, we never know quite what our communication needs are going to be because there's so many exercises with a lot of different use cases. So this set of 6 functionalities, right, like where does that come from? What we used to do is this. We used to have a file for every combination of components. We specified Mixins. These are not React Mixins. We just took the pattern, which is kind of funny now that Mixins are going away. And, you know, that was great. Now we actually don't do that anymore as of 2 weeks ago. We just take a look at the components and say, yeah, OK, we know which Mixins you need. So that's fun. One of these Mixins might be something in the code editor Mixin that says, oh, when you hear the submit event, run the tests. And then the tester adapter might actually have the ability to run the test. It might actually also do some setup when the interface is ready to sort of prepare the testing environment, because that's off running on a separate server. And OK, so we built this like eventing system, whatever. The fun stuff is that under the hood, it was actually really interesting to build because it was much easier than we thought it would be, right? Like at first when we were building like this thing out and like we were trying to rip out all this like callback soup that had grown up in the learning environment, we were like, well, OK, how big of a problem architecturally is this going to be for us to solve? And it actually ended up just fitting into 2 files. So that was fun. We have a base class for the adapter, which just has, you know, some basic lifecycle methods, you know, creates a broadcast function for the components to have. And then we have this creation file that basically takes the adapter prototype and mashes everything that we need onto it, wires up event handlers, manipulates Mixins, and all that. And this is just 120 lines of code. So I think we were really surprised by how easy it was to get it to play with React, that we only need to hook into one place and component did update. All of that like ended up just working, which was a little strange. So does it work? This is like the most basic dumb question I know. Yes, the answer is yes, we use it. And for us, we were really interested to see whether or not this would actually be maintainable, would it scale? Because at first, when we were developing the new front end, we were just testing with a single application, Make a Rails app. We've since started migrating over all of our old courses, so that's Python, JavaScript, HTML, CSS, jQuery, like a bunch of random stuff. As well as we just released a new course, Make an AngularJS app. Yes, I know the irony. OK, so it's written in React, whatever. But we were really happy, actually, when we realized how easy it was to continue adding onto the system. Building a new adapter Mixin tends to be very simple. They tend to be very short. And it's very easy for us to reason about data flow in this way because we built something that was suited like very specifically to how our single-page app works. So looking back at our communication needs, we're actually really happy, right? Again, the first 2 points aren't very interesting necessarily as far as requirements go, but they're really important. And we were really frustrated with the callback soup that we had sort of accidentally generated as we started to explore React 6 months ago. So we've taken care of the first 2. That's awesome. We no longer need to worry about passing state changes up and across the tree because now we just sort of chuck that off to the adapter, and then we're back to unidirectional data flow and pushing things down. So that's great. And this like Mixin system that we have with the adapters has worked really well for us because it just fits perfectly with the way that our app is structured. You know, we have this grid that can have up to like 6 different things in it, and there will always be some combination of things. So that works out well. My next question is, what are we doing wrong? And this is sort of motivated optimistically in the sense that I think there's always things that we can improve, aka there's always something that we're doing wrong. And like I said, when I joined the team, we were all learning React, right, for the first time. We didn't have anyone with us who knew what they were doing. We honestly didn't know if this was like idiomatically React, violating some principles. Like outside manipulation of state felt a little weird to us, to be honest. It was like, well, how will we know that this is actually going to play nice? It's also very specific to our application structure, which I think is a point that I've been stressing because I think it's important. What happens if we have to build like something totally different? And the answer is, of course, well, maybe we'll build another bespoke communication system because it didn't take us that long. And my last point is, should we be looking at Flux? Should we be looking at Flux? That's like the first thing I think that Christopher asked me when I did my rehearsal. Like, how does this relate? Oh, wait. So, I showed this diagram earlier, right? Like, the adapter, it calls that stay on the major components, which broadcasts, whatever. And then as I was preparing these slides, I went and looked back at the Flux docs, which, to be honest, I hadn't looked at in a while. And I was like, these are not the same. But I think there are some patterns here. This whole idea that you do have an outside thing that's sort of dealing directly with your React components is interesting. So one interesting thing that struck me looking at Flux is that it never occurred to us that we would need stores. And I think that's really a quirk of how our app works, just that, like I said, getting data from the server and making sure that we have data consistency just hasn't come up as a pain point. And until it does, it's likely that we're just going to continue to have our adapter setting state directly because we don't need to. Our approach is designed for a very specific scenario. This is not a general approach. It's not a general design pattern. But there are some funny similarities, like the fact that our major components, the web browser, the code editor, the terminal, the instructions pane, they're basically controller views, as far as I could tell. So is this a story of how we accidentally used Flux? I think the answer is not really. But there's this really interesting quote that I want to sort of call out, which is, Flux is more of a pattern than a formal framework, so you can start using Flux immediately without a lot of new code. And this is a quote from the blog back in May. And, looking at this system that we constructed in, what was the quote? Without a lot of new code with 120 lines. It's like, wow, that was kind of true. Even though we are actually using Flux, we did come up with a solution for ourselves, uses unidirectional data flow, that borrows some of the ideas and ditches some of them. It works. It was easy to experiment with. And I think the exciting thing for us is that, now that we have this thing set up, it's actually simple and maintainable enough that we can in the future say, hey, you know what, we probably should have something like a store. And that won't be a huge pain point to transition to. So that was cool. And I think that this conference has been awesome in general for forcing me and, by extension, like a lot of our team at Codecademy to sort of rethink some of the assumptions we'd made about React when we first started. Like one interesting thing, right, is like React says it's just the view. This whole conference has been a lot about the bigger ecosystem outside of the view, which I think is really interesting. Do I want React to be just, wow, I misspelled React, that was silly. Do I want React to be just the view? Well, I mean, yeah, that's awesome, but I also care a lot about the context in which it operates. And another thing we keep hitting is like, how should data flow patterns be treated in the documentation? Like I said, when we first came to React, it was totally unclear to us that like data flow patterns were a thing we should be looking at. And like I said, maybe that reflects poorly on us. But I honestly think that it was a reflection on the rapid state of change in best practices and in everyone exploring how to make things work for them. So I think that, and again, another takeaway we've had is that data flow patterns are important. And there's probably not one answer. But it's important to highlight the fact that you need to think about what you want from your data flow architecture. And I mean this really broadly, right? So what we built these adapter things. It's very small, it's very maintainable, it's modular, it fits our pattern. And that was what we cared about. What happens when you have other priorities? How do you build a data flow architecture that addresses your pain points? Again, I've talked to people who are using Flux like totally as exactly to whatever their interpretation of it is. I've talked to people today who are just using callbacks because callbacks work, and that's a totally acceptable data flow architecture depending on your app. For us, obviously, the answer is that we needed it to do like those two boring communication needs that I had up top. We needed it to work with our code base so that we could still have legible, maintainable code. And like that's a very minor sort of goal. It seems like pretty unambitious, but for us, I think it was important to keep that in mind, that we didn't need to take something massive in order to get everything that we wanted, right? We can keep the idea of a dispatcher and controller views, and it works. So I deliberately left a lot of time at the end because I'm really interested to hear what people have to think about these. So thank you all, and I'd love to have some questions. Anybody?
So in one of your code snippets from earlier, it looked like all of your actions were just namespaced strings with colons between them. Do you think that might wind up being a pain point later on?
So the cool thing is that namespacing happens automatically. So when I showed, let's see if I can find the snippet. This is actually something that we liked a lot about what we ended up doing. All the button needs to do is say submit, and it gets that broadcast function from something that actually performs that text transform. So yes, this is sort of a weird, like maybe not the most intuitive way to do it, but for us it means that we didn't have to worry about namespacing. We just made the adapter do it kind of secretly on its own. So I think it works well for us, and we'll continue to scale for our needs.
Cool, thank you.
Thanks. Cool. Okay.
No more questions, anyone? Oh,
Oh,
go ahead.
sure.
Sorry.
Cool.
Should have danced or something.
Sorry, the lights are bright.
So now that you've gone through all that and Flux has gotten a little bit more attention, I guess, and more people have used it, have you ever thought about, okay, what objects do I have and what roles are those playing in that the Flux objects are, like that you've got your adapter, but then Flux has a dispatcher and stores and other things like that. Have you kind of thought about what roles your pieces are playing that are played in the objects in Flux?
Yeah, I've been thinking a lot about, let me see if I can get back to the slide I want. I've been thinking a lot, actually, especially over the last week, about like how these ideas map onto each other. And I think our biggest takeaway is that, up until now, we haven't really been forced into making a sort of coherent model of a lot of things, right? Like we have, for example, a test, like when tests are running, there's very specific state that changes that only impacts one component. I think for us, the biggest challenge with Flux would be figuring out how to like sort of abstract that out and figuring out whether or not that's sort of premature optimization. So the answer is I'm really not sure.
Cool.
Thanks. Hi.
Hi. So I'm thinking you're teaching people to program, and my main question is do you guys have any notion of code sandboxing using React or using the data flow you described?
So code sandboxing, fun fact. So I alluded to earlier that we sort of rewrote the front end because we wanted to support more interesting things on the product side. At the same time, we did a total rewrite of the back end because it's one thing to say run code in a sandbox. It's harder to say run a web server, just like, I don't know, where would you run it? So the answer now is that each user actually gets their own Linux box spun up, provisioned, and then we run their code. All that they could do is break their own box. So
cool.
Yeah, thanks. Cool. So thanks, everyone.